In this video, we will be covering section 1.3 of college algebra on equations of two variables. The first topic in this section is given 2 points, finding the distance between those 2 points or finding the midpoint between those 2 points. So the distance would be, oh man, I'm not going to be able to draw straight lines on here very good. The distance would be the length of the straight line segment connecting 2 points, right? So if we're given 2 points like this, we want to find the length of a line segment connecting those 2 points. To measure that length, it's difficult to do algebraically. What is easier to do is to measure the distance horizontally and then vertically between those 2 points. Oh gosh, okay, let's try that again. Vertically, all right. So we'll measure the horizontal distance between the 2 points and then measure the vertical distance. And measuring the horizontal distance is easily done by just subtracting the x-coordinates, and that'll tell you what that gap is. And then to measure the vertical distance, we just subtract the y-coordinates between those 2 points, and that'll tell us the measure of the length of that gap. And so we'll find this measure first, we'll find this measure second, and what we'll do is use those two results to find the measure of the diagonal line, which you could call C, for example. And so what you end up constructing here is a right triangle. And so the Pythagorean theorem is how these lines will be related. And so it'll just be a squared plus b squared equals c squared. Except that instead of a squared, we're going to represent that as x2 minus x1. The order you subtract them in really doesn't matter. But to get that length, we will subtract the x-coordinates and then have to square it. For b, we will subtract the y-coordinates to get that length, and then it has to get squared. And then c is the distance that we're looking for, so we just call that d. And so that's how this formula comes about. So you don't need to know how to derive the formula, but I think it makes it easier to remember it and to understand how to use it if you think of it as just the Pythagorean theorem. This is literally just a squared plus b squared equals c squared. For the midpoint formula, we use this notation, which is a line above the variable. So this is read as x bar, and this is read as y bar. Whenever you see the bar notation above a variable, it literally means to take the average of those values. So this is asking us to take the average of the x values. So we want to average out the x's. So I don't know, maybe I should make that a more complete sentence. So we'll take the average of the x's for the x coordinate and then take the average of the y's to get the y coordinate. With 2 points, you will have two x values. To find the average of those two x values, you add them together and divide by 2. So again, this formula looks fairly complicated, but I think it makes it a little bit easier to remember and to use if you just think of this as doing an average. I'm averaging my x-coordinates, and then I'm averaging my y-coordinates. So let's apply those concepts to this particular problem here. Find the distance between the 2 points and the midpoint of the line segment connecting them. Sorry, I'm using my own words. Of the line segment joining them is what I should have said. All right. So first we'll find the distance. So we have d squared equals x2 minus x1 squared plus y2 minus y1 squared. I'm going to plug these points in for x's and y's here, but I want to make sure I do it appropriately. So I always recommend labeling these points before plugging them into a formula like this. And so this first point is an x value and a y value. Since it's my first point, I'm going to label these with 1s. This point also has an x and a y coordinate, but since it's my second point, I will label those with 2s, and then I will plug these numbers in the way they're labeled. So x2 is going to be -3 minus x1, which is -2. So be careful because you're going to get a double negative here. Minus sign from the formula, negative sign in the number. So we'll have to be careful when we simplify that. Plus, we'll take y2, which is -1, minus y1, which is 3, and then square that. So we just need to simplify here. This is going to become a +2, so we get -3 plus 2, which is going to be -1 squared plus -1 minus 3, which is going to give me -4 squared. We square both of these, so -1 squared gives me +1, -4 squared gives me 16, 1 plus 16 gives me 17. So be careful, a lot of students will say, okay, my answer is 17, but that actually is not the distance. That is the distance squared. So I didn't really copy this down all the way like I probably should have, but I'll go ahead and bring it down now. The distance squared is 17. So to solve this for the distance, we'll have to take the square root of both sides, and we'll get that the distance is the square root of 17. All right, so that's how you find the distance. For the midpoint, we'll use this formula, x1, sorry, not x1, said the wrong thing, x bar, comma y bar. And remember, the bar means we're taking the average. So to average the x values, we will add them together, so x1 plus x2, and divide it by 2. And for y bar, we're going to average the y values, the y coordinates. So y1 plus y2 divided by 2. And we have the formula set up as an ordered pair because this is a point that we're finding. All right, so we'll plug the numbers in the way they're labeled, just like we did in the last formula. x1 is -2 plus x2, which is -3, divided by 2. For the y's, we're going to have y1, which is 3, plus y2, which is -1, divided by 2. So then we simplify. Let's switch colors here. -2 plus -3 will be -5 over 2. So we get a fraction. We try to reduce it if we can. This doesn't reduce, so we'll just leave it as a fraction. Comma. Here, 3 plus -1 is going to be +2 over 2. That does simplify, so make sure you simplify it if possible. So we'll have -5/2 for x, and then we'll have 1 for y, right? 2 divided by 2 would be 1. And so there's my midpoint. This is the point that would be exactly halfway in between these 2 points. Okay, let's move on to another topic. So the main topic in section 1.3 is this topic here, circles. A circle is the set of all points that are say that again. A circle is the set of all points that are the same distance away from a given point. So I'm sure all of you know what a circle looks like, right? We think of a circle. I'm not going to be able to draw it, actually. Let me see if this thing has shape tools here. Let me see if I can do a circle shape. Here we go. So this is what a circle looks like, right? Okay, there we go. I could never draw that by hand. So we think of this shape when we see the word circle, but mathematically we need something more rigorous as the definition. And so this is the definition that we get mathematically, which is kind of interesting because this is what a circle looks like on a flat surface, which is how we all imagine it. But this definition could be applied to other types of surfaces. So you can have curved surfaces where, I'm sorry, I was trying to make this go away, but it's not going away. So I'm a little bit worried about that. Where the shape may not look exactly like this. So you can get different kinds of shapes, even though the object is still technically a circle because it satisfies this definition. All right, so we have a given point, which is this point here. Maybe if I click down here, I'm sorry. Okay, that worked. I was kind of worried about that being stuck there the rest of the video. All right, so here's the given point. And from this point, we asked for all the points that are the same distance away. So there's some particular distance here, and all of the points on the circle are the same distance away from this point here in the middle. So I'm really trying to avoid using the technical term for these two things. I'm just trying to, keep it hidden until I was ready to reveal it, but it's really hard to do. So this point here in the middle that we're measuring the distance from to all these other points, it's a pretty basic, simple name. It's the center of the circle. So this given point that's referred to in the definition is called the center of the circle and is often represented by the letters h, k. So it's going to be some point. So this circle is going to be on a Cartesian coordinate system, and that center will have an x coordinate and a y coordinate, which we label as h and k. The distance that these points are away from the center has also a special name that you might be familiar with. It's called the radius, right? So whatever this distance is, Whoops, I can't spell. It's called the radius of the circle, which is often just abbreviated r. So this distance that we're referring to in the definition is the radius. Now, if you think about the definition, we have this point here, which is at h comma k, and we have some random point on the circle. There's lots of them that we could choose from, and because they vary, we can represent this point as a couple of variables, right? So whatever point you want to pick on the circle will work here. The distance between any point, which we're labeling x comma y, and the center, which we're labeling h comma k, is given by this distance r, the radius, right? So the distance here would be r. So essentially, a circle is an application of the distance formula. So if you take the distance formula, which is d squared equals x2 minus x1 squared plus y2 minus y1 squared, and you plug this information into the formula for distance, you get this equation here, right? So we're going to plug in h, sorry, I said the wrong letter. We're going to plug in x in place of x2. We'll plug in h in place of x1, because those are my x coordinates, right? We have h and we have x. We're going to subtract those two, and this is the order we'll subtract them in. Again, technically you could do it the other way, but this is the standard way of doing it. For the y coordinates, we have y as one of our y coordinates, and we have k as our other y coordinate, so we subtract those. So we get y minus k squared. And instead of calling this the distance, we have a special name for that distance. We're calling it the radius, and so we'll plug that in for d. So we get r squared. And so you kind of flip that around the other way, and you get what you see on the screen here, right? So this is the formula for the equation of a circle. H and k are your center, and r is your radius. All right, so we're going to be using this formula to do the next several problems, so you'll want to make sure you know that formula. All right, let's take a look at an example. So here we're given an equation. We have, I'm going to write it over here a little bit bigger. We have x plus 5 squared plus y squared equals 25. The directions are asking us to find the center and the radius, and then to use that information to graph the circle. All right, so to find the center and the radius, we will compare the equation we're given to the formula that we just developed. So we have x minus h squared plus y minus k squared equals r squared. And then all we have to do to find the center and the radius is to line up this formula with our equation and find h and k and r, and then we'll know the center and the radius. All right, so the center is at h comma k. Now there is one thing you have to be very careful about when you're identifying h and k from the equation. So if you look at how the formula aligns with our equation, we have x here, those line up with each other. So the h appears to be lining up with the 5, except for one discrepancy. In the formula, we have a minus sign. Let me try that again, the arrow here. Or we have a minus sign, whereas in our equation that we were given, we have a plus sign. So those don't actually match up like they're supposed to. So technically what I need to do here is rewrite my equation to have a minus sign to match up to my formula. I can rewrite x plus 5 as x minus negative 5 squared, right? So a plus sign could be rewritten as minus a negative. Then we have a minus sign matching up with the formula, but now h is going to line up with negative 5. So most students don't bother to rewrite the equation like this to get that alignment just right. What most students remember is that h will just be the opposite sign of whatever number is here. So we have a plus 5 next to the x, which means our value for h will be the opposite sign of that. It will be negative 5. All right. So we get negative 5 for h. This one's also a little bit tricky. There is no number here with y, which means k is equal to 0. If the number's missing, the only way it could be invisible like that is if it's equal to 0. So k is equal to 0. So there's my center. My center for this circle is at negative 5 comma 0. So I can actually mark that point on the Cartesian coordinate system. It's right here. So there's where the center is located. The radius we get by lining up the right-hand side of our equation with our formula. And be careful about this issue as well. Some students will make this mistake. They'll say the radius is 25, but that is not exactly correct. The radius squared is 25, right? The square of the radius equals 25, so to find the radius, you actually have to take the square root of that number. And in this example, the radius will be equal to 5. So the center is at -5, 0. The radius is the square root of 25, which will be 5. That means my circle is going to be all of the points that are 5 units away from this point here at -5, 0. Now, like we talked about for the distance formula, it's difficult to measure out 5 units going in diagonal directions. So to find points here to help us draw our circle, the easiest points to find are vertically and horizontally from the center. Those are easy to measure out, they're easy to count. So I can go 5 to the right of my center, and I'll get this point here at the origin, 0, 0. I can go 5 to the left, which will take me all the way out to -10. So I know that's exactly 5, that's exactly 5. I can go 5 up from the center, which will be here at -5, 5. And I can go 5 down from the center. So I'll be at -5, -5. Those are the points that you want to work with when you're drawing a circle by hand. You don't want to try to find a point that's 5 units in a diagonal direction because that will be hard to estimate. On Math Excel, you won't need to have all 4 of these points, you just need 1. So you mark the center on Math Excel, you pick one of these points, and then Math Excel figures out the rest of them for you. So you just have to do 1 point like this. But on our exam, when you're drawing this by hand, it's helpful to have all 4 of these points as guideposts to help you draw your circle. Now I'm kind of talking on a little bit longer about this because I'm hesitant to want to draw this circle because I'm going to butcher it. So I'll do my best. It's just this writing pad, it's difficult to write on the screen. So I'm not writing directly on the screen. That might be a little bit easier. I'm using a tablet that doesn't display where I'm writing. So it just makes it, I'm kind of writing blind, if you will. So, and it's just really shaky. It's hard to do. So I'm tempted to use the circle drawing tool again, but I don't know if I'll be able to do that right. So let me go ahead and try to do this by hand. So I'm going to start with this point. I'm just going to connect these 4 points in as much of a circular fashion as I can. So this should look like a circle. I'm not going to be picky on the exam if it's a little bit messy, as long as it's not like jagged edges. If you draw like a diamond, you're going to lose points for that. But so here we go. Okay, that's not too bad, I guess. Connect the 4 points. Oh, I kind of missed that one. Okay, so that's the best. I'm not even going to retry it. I'm just going to leave it like that. You get the idea. Connect these 4 points as a circle, and that's what your graph should look like. All right, let's take a look at another example here. So this one is a little bit scrambled up. To match it up to the formula for the equation of a circle, we really want to have our x's and y's on the same side of the equation. So I want to actually bring this y over to the left-hand side. To do that, I'm subtracting it over here. So what I'm going to do is I'm going to add this thing over to the left-hand side. So this will not change. So some students will make the mistake of putting y minus 2 here to do the opposite sign of plus 2, but you actually don't want to change that. You're doing the opposite sign here, and then this should just stay the same. So we're going to do y plus 2 squared, add that to the other side. So we're going to add the y plus 2 squared over to here. So our equation becomes x minus 2 squared plus y plus 2 squared equals 27. We will compare this to our formula of x minus h squared plus y minus k squared equals r squared. And from that, we should be able to figure out our center and our radius. All right, so the center will be at h comma k. So remember, the shortcut here is that whatever sign you see with the number in the equation, you want the opposite sign in the center, in the point for the center. I'm having trouble thinking of how to describe it. So whatever you see in the equation, when you go to write your coordinates for the center, you want the opposite sign. Maybe that's a better way to say that. So we have minus 2 here. So for h, we will use positive 2. It's going to be the opposite sign of that. And then for k, we have a plus 2 here. So in the coordinates for my center, I will use a negative 2 for k. And so my center is located at 2, negative 2. The radius in this case is not 27. The radius squared is 27. So to find the radius, we will have to take the square root of both sides. And unlike the last example, this does not simplify nicely. So we'll get r equals the square root of 27. Now if you type that into Math Excel, so currently Math Excel is asking for the center, which you'll type in 2, negative 2. So that's going to go here in this box. Once you get that answer correct, it will then ask you for the radius. And if you type in the square root of 27 as your answer, it will not give you credit for that. You need to simplify this. And this is something that in this course, we don't teach how to simplify radicals. It's assumed that you already know how to do this if you're in college algebra. But I'll go ahead and refresh your memory real quick here with this one. So the square root of 27, you can't take the square root of that as a whole. So what you will do is you'll split it up into two numbers where at least one of the numbers you will be able to simplify. You will be able to take the square root. So for 27, we want to split that up as 9 and 3. So we'll have the square root of 9 times the square root of 3. So that square root applies to both of those numbers. And then the square root of 9 simplifies. So we get square root of 9, which becomes 3. The square root of 3 just copies down. And so my radius is going to be 3 square root of 3. Now I didn't put this on the screen when I did the screen grab for this homework problem, but because the radius is not nice, the graphing tool won't work. So this one's going to be multiple choice. So you'll be given 4 different graphs to choose from, but I didn't want to use the multiple choice. So we're going to draw this one by hand. I'm going to try to set this up. Oh, it's so hard to do on here. Straight line for the y-axis. Oh, it's not too bad actually. And then straight line for the x-axis. Okay. I just got to hold my breath when I do it, I guess. And then we'll plot this point, the center, which is at 2, negative 2. So 1, 2, and then negative 2 on the y-axis. So my center is located here. And then I want all of the points that are 3 square root of 3 away from the center. But I don't know how far that is, right? How far is 3 square root of 3? So we will need to use a calculator to estimate it. So I want to get a decimal for this. Now, it's important to realize that for Math Excel, I don't want to type a decimal in for my answer. I want to type this in. So Math Excel wants the exact answer with the radical. But if you're going to graph this by hand, you need to have some idea of how far that is. So we want to think of it as a decimal for the purposes of graphing. So I'm going to go ahead and, I wasn't prepared for this actually, so I'm using my phone. So I'll do square root of 3 first. So square root of 3 times 3. And so I'm going to get 5, and I just need 1 decimal place. I can't really draw it that accurately. So if you round to 1 decimal place, it's about 5.2. So I want to go 5.2 away from the center. And remember, just like the last example, the easiest points to find that are that distance away are vertical and horizontal. So I'm going to go 5.2 up, 5.2 down, 5.2 to the left, 5.2 to the right from the center. So I'm going to start here, and if I go 5.2 up, I'm going to go 1, 2 to get back to the x-axis, and then I need to go 3 more, 3, 4, 5, and then a little bit further beyond that to get the point 2, right? So this gets me back up to 3, and then I'm going to go a little bit past the 3 to mark my point. I will go 5.2 down. I didn't really leave myself enough room for this, so let me try to extend the axis a little bit. Probably got to do the same thing here. And this graph might really come out looking pretty horrible, but let's see what we can do. So 1, 2, 3, 4, 5, and then a little bit beyond that, right, to get the point 2. So that's going to be about 5.2 down. So this will be at negative 7.2. Then I'm going to do 5.2 to the left. So starting from here, 1, 2, 3, 4, 5, and then a little bit further to get that point, and then 5 to the right. 1, 2, 3, 4, 5, and then a little bit further for the point 2. All right, so there's my 4 points that serve as my guidepost. I'm going to try to connect these 4 points as a circle. It already looks a little bit smushed. It looks a little bit off. And I'm sure I'm going to make it look much worse when I go to actually draw these. So that should be more of an arc there. All right, and then, oh gosh, okay, I'm going to start over. Let's try that again. Okay, let's just do one thing at a time. So we'll do that one first, then we'll try this one, and then we'll try this one, and then we'll try this one. All right, that didn't turn out too bad. Okay, so that's how you graph circles using the center and the radius. The other type of problem that you will have concerning circles is they will give you information about the circle. Sometimes they'll give you the graph even, and then you want to work backwards to figure out what the equation is. So this is probably the easiest version of that type of problem. They're giving us the center, they're giving us the radius, and we want to find the equation. So it turns out the formula that we have for the equation of a circle has a spot for us to plug in all this information. So we have x minus h squared plus y minus k squared equals r squared. So remember, the center is at h comma k, the radius is r, so we have a place to plug all these numbers in. So I'm going to plug in 8 for h, I'm going to plug in -2 for k, and then I'm going to plug in 1/5 for r. Now you got to be careful, because I know with the other couple of examples that we just did, I said you have to change the sign of the number when you're setting up the center, right? So whatever's in the equation, you take the opposite sign when you're setting up the center. You don't have to do that going in this direction because the formula does it for you, right? The minus sign in the formula is going to change the sign of this number, right? So this is going to become x minus 8, right? So it started off as positive 8 in the center, but when I set it up in the equation, it's going to be -8. The formula takes care of it for us, so we don't have to manually do that ourselves. Same thing's going to happen here. We'll have y minus -2, so the double negative will make this a +2. And so again, we get the opposite sign. It started off as -2 in our point, but once we have it in the equation, it's going to be a +2. So the formula takes care of it, so you don't have to. All right, I'm going to copy this one down. And then for the radius, we want to square it, right? So whatever the radius is equal to, we have to raise it to the second power. And it's a fraction, and that kind of makes some students a little bit nervous about it. But squaring fractions is really not as bad as it looks. All you have to do is apply that power of 2 to the top and bottom. So 1 squared gives me 1, and then 5 squared gives me 25. And that's all there is to that. So this would be the equation of a circle with center at 8 comma -2 and a radius of 1/5. This is what the equation would look like. Unfortunately, and I hesitate to say a problem is easy, because in college algebra, there's really no such thing as an easy problem. They're all fairly challenging. So this isn't necessarily a completely easy problem, but this is the easy version of this type of problem. So from here, the problems are going to get a little more difficult. So let's take a look at the next one. This time we want to find an equation with center at 2 comma 8. So far it's the same as what we just dealt with, except this time they do not tell us the radius. So they give us another point to work with. So we have a center at 2 comma 8, and the circle passes through the point 3 comma -1. So they don't tell us the radius. Now what you could do to find the radius is to find the distance between these 2 points. So whatever that distance is, that will equal the radius for the circle, right? It's from the center to a point on the circle. That's the radius. So if you look at Math Excel, that's the way they're going to advise you to proceed. They're going to say, take these 2 points, use the distance formula, that'll tell you the radius, and then you can do the problem just like we did the previous example, once you have the radius. But I think there's an easier way of figuring out this information. We still have to find the radius, but you don't have to think of it as applying a whole separate formula to find it. So what you can do instead is go to your formula for the equation of a circle, x minus h squared plus y minus k squared equals r squared. Plug in what you know, right? So we know the center, so we'll plug in 2 for h, we'll plug in 8 for k, and we'll copy the rest of it down. So we'll have x minus 2 squared plus y minus 8 squared. We don't know the radius, so we'll just leave that as r for right now. Since that's the only thing we have left to figure out, what we can do is plug in a point for x and y in this formula, and then we can solve for r, right? So if we can plug in a point here for x and y, r will be the last variable, and we can solve for r to figure out what r is equal to. So instead of using a whole separate distance formula to figure out r, we can kind of figure it out within the equation of a circle itself. So I'll take this point that they gave me on the circle, and temporarily, this is only temporary, we'll temporarily plug that in for x and y, right? 3 is the x coordinate, -1 is the y coordinate. We'll plug that in for x and y. So we'll have 3 for x, so we get 3 minus 2 squared here, and we're going to get -1 for y. And now we can solve this for r. So we're going to get 1 squared here plus -9 squared equals r squared. And so that's going to be 1 plus 81 equals r squared, right? 1 squared is 1, -9 squared will be positive 81. And so we'll get 82 when we add those together, right? Now, I kind of have to pause here because this is as far as you need to go, right? So think about what was missing from your answer. You have the left-hand side figured out. All you need to have your final answer here is the right-hand side, which is r squared, which is what you have here in this result. You don't really need to know r. You want r squared. So you can stop here. This is where I advise students to stop working and then substitute. Replace the r squared in the formula with what it's equal to in this result here. So I'm going to swap out r squared for 82. You don't have to square the 82. It's already squared, right? This is r squared. It's already the radius squared, so we don't have to square it again when we put it in the equation. We just merely exchange the r squared with the number 82. So our final answer, I'm going to replace this with 82, and my final answer will be x minus 2 squared. So again, we go back to having x and y. The 3 and the -1 were just temporary. Once we have our result, we go back to our variables x and y. So I'll have x minus 2 squared plus y minus 8 squared equals just 82. Not 82 squared, just 82. If you don't like that, so some students are kind of like, that doesn't feel right to me. It doesn't make sense. You can proceed further. You could say, well, I have r squared's 82, so to find r, I take the square root of both sides, right? So you get r is equal to the square root of 82. You plug that in for r, but what's going to happen? You plug that in for r, you're going to have the square root of 82 for r, and then that has to get squared, and then the square cancels out the power of 2, and you still just get 82. So it's a little bit of extra work to get you to the same place. It's a little bit unnecessary, but if that's what you feel more comfortable with doing, then you should do it that way. Either way, you should end up with this as your equation. All right, so that's the equation of the circle with a center at 2, 8 and passing through the point 3, -1. All right. Unfortunately, there's one other type of problem involving circles, and then we have, this section just has a lot of stuff in it. We have a couple more things to talk about that are not quite as bad as these circles are. So this last problem involving circles is, it requires understanding this process here of completing the square. So what that is referring to is taking the first two terms of a trinomial, where you have x squared as your first term plus bx as your second term, and finding a number to add to this, right? We don't know what this should be, so that I can factor it as a perfect square, which means you're getting the same factor twice, right? So you want these two to be the same. So it could be like x minus 5 times x minus 5, which means you can write it as x minus 5 squared, right? So now we don't know if it's going to be a 5. We don't know what that number actually will be yet until we have more information. But that's the goal, is given this number b, what number would I need to add to this so that it will factor as something to the second power? The reason we want to be able to do that is because in the formula for the equation of a circle, that's the kind of expressions you're dealing with in there. You have x minus h squared, y minus k squared. So if your equation doesn't already have those things being squared, you can do the work to write it that way by following this process. And it's not that hard of a process. It's kind of complicated, but it's not really, no individual step is really that hard to do. You find b, whatever b is equal to, you divide it by 2, so you'll get a result from that. Sometimes it'll be a fraction, sometimes it won't. You square it, you raise it to the second power. Whatever you get from that result, that is the magic missing number that you need to add to this expression to make it factor the way you want it to factor. So that's step 4. Add this result to both sides of the equation. So we're going to be dealing with an equation. So whatever you add to this expression on the left-hand side, you have to add the same thing to the right-hand side. Then you should be able to factor this as a perfect square. If you get nice numbers here, you probably will have no problem factoring it. You won't need any assistance. But sometimes you're going to have a fraction. And so if these are fractions, the way it will factor is x plus b divided by 2 squared, where b divided by 2 is the result that you had from step 2. So you take b, you divide it by 2. Whatever you got from that result, that's what ends up inside the factor when you factor it as a perfect square. So that's a shortcut you definitely want to be aware of when you're dealing with fractions. Okay, so let's look at a couple of examples of this. So we have x squared minus 12x. And what I'm going to do in rewriting this problem is I'm going to leave an empty space because I don't want my equation to look like this, right? For a circle, the equation should look like x minus h squared plus y minus k squared equals r squared, right? That's the way we need our equation to look. This doesn't look like that, right? We have x squared, but then we have minus 12x. So we need to rewrite this to make it look like this. And so we're going to use the completing the square process to figure out how to make it look this way, which means I'll have to add some special number here so that it will factor like this. So I'm going to leave a space for that special number, and then I'll write the plus y squared minus 16y, leave another space because we'll have to do the same thing for the y variable, equals 0. All right, so let's start with the x variable. To complete the square, to make it look like this, we will take b, which for x is negative 12. So let me maybe do this over here. So this is for the x variable. Step 1, b is equal to negative 12. Step 2 is you'll divide both of those by 2. So b divided by 2 gives you negative 6. Step 3 is to square that. So I'm going to take negative 6 squared, which is going to be 36. Right. So if you want to keep track of it on the left-hand side here, this is b divided by 2 squared. I kind of don't bother with labeling it. It's just take that number, divide it by 2, raise it to the second power. We get 36 when we do that. That's the special number that we need here for this to factor the way we want it to factor. So I'm going to add a 36 to these x's, to this group of x's here. If I add 36 to the left-hand side, I have to add 36 to the right-hand side as well. I have to keep the equation balanced out. Now I can factor this, and this will factor. We don't need the shortcut this time. We should know how to factor this one. To factor a trinomial that looks like this, all you have to do is find two numbers that multiply to 36 and add to negative 12. And the two numbers that will do that are negative 6 and negative 6. Right? Negative 6 times negative 6 is positive 36. Negative 6 plus negative 6 is negative 12. We get the same factor twice, which was the critical thing that we needed. We wanted this to be the same factor twice so that we could write it as x minus 6 squared. And now it matches up to the formula. And I can see that h is equal to 6, right? Again, take the opposite sign of that number, right? It's equal to positive 6. Now I can get the center. So what I would like you to do is pause the video and try to do the y variable yourself. Do the same process to complete the square for the y variable. When you've finish that attempt, resume the video, and check to see how you did. All right, so what you should do for the y variable, I'm kind of out of room here, so I'm just going to kind of do this verbally. I'll take b, which is negative 16. I'll divide that by 2, which is negative 8. And then I square the negative 8. I guess I could just do it up here, right? So I have negative 16 divided by 2 gives me negative 8. Square that. Sorry, I'm erasing while I'm writing, which gives me 64. All right, so you should have got 64 here as your special number that you need for this to factor the right way. If I add 64 to the left-hand side, hopefully you remember to add that to the right-hand side. And then to factor this, you want two numbers that multiply to 64, but add to negative 16. That will be negative 8 and negative 8. Let me just point out that in both of these cases, the shortcut would have worked, right? So the number you end up with inside the factor is what you had here in step 2 when you divide it by 2, right? b divided by 2 is negative 6. Negative 6 is what I get in my factor. Here, the b divided by 2 is negative 8. Negative 8 is what I end up with here. So I'm going to have y minus 8 squared. Sorry, there's a button on this pen. It's hard not to grip it where the button is, but when I push the button down, it erases while I'm writing. And so that's why I'm having trouble now for some reason. So equals, you add these numbers up over here, and this is kind of a nice result. You get 100, right? Now I can find the center and the radius. So compare your formula to the equation you have. The center, again, will be at h comma k. H in this case will be positive 6, comma k will be positive 8. So the center is at 6 comma 8. The radius is going to be 10. Right? So the radius squared is 100. To get the radius, you take the square root, and you get that the radius is 10. All right, so that's completing the square. All right. Again, in the case where you get a fraction, I showed you that shortcut that you could use to get the factor. You might have one or two of those on the homework where you have to use that shortcut. Unfortunately, I'm kind of running out of time. I don't want this video to be more than 50 minutes because that's how long a class period is. So I don't have any more examples on my lesson for that type of problem. Rest assured, though, that I don't know, maybe I shouldn't say this. I don't think I have completing the square on the exam. So there's some on the homework, but I don't think there's any on the exam. So we'll see when we look at the practice exams if there's any of those questions on there. So the last topic in this section really doesn't belong in section 1.3. 1.3 is really mostly about circles. These problems will have nothing to do with circles. So finding the x and y intercepts. You could find these for circles, but they don't ask you to do that. It would be really complicated to do. Instead, they're going to give you linear equations to find the x and y intercepts. And you might say, well, what are linear equations? That's a good question. We haven't actually introduced them yet. That's what the next section is about. So section 1.4 is on linear equations, but we're going to be using linear equations in 1.3 anyways, because they kind of assume you already are familiar with it. So I apologize. It's a little bit out of sync with the material, but it's in section 1.3, so I'm going to go ahead and cover it now. So finding the y-intercept. The y-intercept is where the graph, let me just go ahead and write out all the words, where the graph crosses the y-axis. All right. So the y-intercept or intercepts, some equations can have more than one. But for linear equations, there's just going to be one. All right. The x-intercept is where the graph crosses the x-axis. Sorry, I kind of lost my thought there for a second. Where the graph crosses the x-axis. Okay. So to find those particular points, where is it crossing the x-axis? Where is it crossing the y-axis? This is the process for doing that. And let me just explain why this process works. So if you have some kind of line that's crossing through here, and you want to know, well, what is this point here on the y-axis? One thing you know about this point, now whenever I ask my class about this, I'll say, what's one thing you know about this point? For 100% no. And they'll say, well, the y-intercept is positive. And that is true, but there's something you know even more than that, right? So yes, because of the way this is drawn, we can see it crosses where the y-axis is positive. But even more so, we know that the x-coordinate here has to be 0, right? So in order for the point to be on the y-axis, the x-coordinate has to be 0, right? Because it lines up with 0 on the x-axis. So it's going to be 0 comma something, right? And this is supposed to be a question mark here. 0 comma something, which will be positive in this case. But we know for sure that the x-coordinate is 0. So to find the y-intercept, you set x equal to 0, because to be on the y-axis, the x-coordinate has to equal 0. Then you solve for y to find out what that y-coordinate actually is. Conversely, for the x-intercept, this point where it's crossing the x-axis, the one thing you know for sure here is that the y-coordinate would have to be 0, right? Because it lines up with 0 on the y-axis. We don't know what that x-coordinate is. I'm really unable, oops, I hit the wrong button. I'm unable to draw question marks for some reason. So let me try that a little bit better. Okay. So it's going to be something comma 0, right? So to find the x-intercept, the y-coordinate would have to be 0 for that point. So you plug in 0 for y, then you can solve for x. All right, let's take a look at a couple of examples. All right, so we have x equals 3y minus 90. Got some big numbers here, but notice the Cartesian coordinate system here is going to accommodate those large numbers, hopefully. Looks like I'm cutting it off here a little bit with where I'm recording, so hopefully it doesn't extend into that. I think it does, actually. So, okay. So to find, let's start with, I always do the y-intercept first. So let's do the y-intercept. Step 1, you're going to plug in 0 for x. Right? So I'm going to set x equal to 0, so I get 0 equals 3y minus 90. Right? So my equation is x equals 3y minus 90. I'm going to set x equal to 0 for step 1. And then for step 2, I solve for y. So to solve this for y, I will add 90 to both sides. And I'll get 90 is equal to 3y. Then we divide by 3 on both sides. We get y is equal to 30. So there's my y-intercept. My x-intercept, we find that by step 1, set y equal to 0. So we're going to take this equation, same equation, x equals 3y minus 90, and we will set y equal to 0. When you set this equal to 0, 3 times 0 is just equal to 0. 0 minus 90 is just going to be negative 90. So sorry, I didn't put step 2, but step 2 is now solve this for x. You get x is equal to negative 90. Now I'm being a little bit careless here on purpose. A lot of students will leave their x and y-intercepts as I've written them on the screen. And it's technically acceptable because it's assumed people will know what you mean. So when I say, oh, the y-intercept is 30, you know that I mean that the graph will cross the y-axis at 30. So it's the point that's at 30 on the y-axis. That's what I mean by that. When I say the x-intercept is negative 90, that's really not the proper way to describe that, but you know what I mean. You mean, or I should say this, I mean, so when I say the x-intercept is negative 90, I mean the graph crosses the, I can't even talk right now. Oh man, maybe I should re-record this. I'm so close to the end though, I don't want to start over. So what I mean by that is that I'm talking about the point that's at negative 90 on the x-axis. That's what I'm trying to say, right? Okay, which will be this point here. But sometimes students will make the mistake of joining these two numbers together. And it's an easy mistake to make when you have an x and a y. You want to naturally put those two things together because x coordinates go with y coordinates, right? So sometimes on the test, on the homework, on the quizzes, I'll see students do negative 90 for x, 30 for y. And they'll write it like this, which is a horrible idea. You don't want to take these two numbers and put them together like this. Now, sometimes students write it that way, but they still graph it appropriately. But I will get students who write the intercepts this way, and then they think, well, this is my point, negative 90 comma 30, and they'll mark this point here, which is absolutely incorrect. That point is not on this graph. That is not a point that we should be getting for this equation. So let's undo that point, and let's actually just cross that out. Don't write your answer in that form. It'll really make me question if you understand that these are two separate points. So if you want to pair this up with something, The y equals 30 pairs up with the x equals 0. These are the things that pair together. So it's going to be 0, 30, which is the appropriate way of describing a y-intercept. You shouldn't say the y-intercept is just 30. The y-intercept is a point. It should have an x-coordinate and a y-coordinate. So the y-intercept, the proper way to describe it would be 0, 30. For the x-intercept, again, we'll link these two together, right? The negative 90 goes with 0 for y, not with the 30. So it's these two that should pair together, and we get the point negative 90, 0. So that is the appropriate way of describing the x-intercept. And that matches the 2 points that we have here. And then they want us to graph this equation without actually ever having told you what this graph should look like. So these kind of equations where x is to the first power and y is to the first power, as long as the x and y are not multiplied together, are linear equations, which means the graph will be a line. And to graph a line, all you need are 2 points. We have 2 points here, so we can go ahead and graph the line using these 2 points. You just connect the 2 points with a straight line, which I'm afraid I will be unable to do. So I'm going to try to use this graphing tool here, which I already messed up on. Let's undo that. All right, and let's use a different color. All right, so we're going to go from this point here to this point here. So straight line connecting those 2 points, however you got to do it. I really messed that up too. Let's try it again one more time. Okay, sorry, this video is getting a little bit long. I feel like I'm getting a little bit loopy here. And it really should go in both directions. So I know it's a little bit crooked there, but all the way to the left, all the way to the right would be a good idea. All right, so it's going to go like that. So there's our graph. All right, I think I just have a couple more examples to look at. Let's see if we can go through these quickly here. They also, for some reason in 1.3, want to talk about these special lines that we're going to see again in 1.4, but they want to introduce them now. Vertical lines and horizontal lines. So vertical lines go this way, up and down. Horizontal lines go this way, left and right. And these types of lines have special equations that describe them. So to describe a vertical line, I have these backwards. Oh gosh, this is a horrible mistake. It should be x equals h, and this should be y equals k. So I'm sorry I had these backwards. So to describe a vertical line, it's x equals h, which is just a number. So oftentimes I'll write it like this. X equals some number. That gives you a vertical line when you graph it. And y equals some number gives you a horizontal line when you graph it. So I'm really sorry about this. I need to go back and fix that in my notes. All right. So these are special lines. So x equals 6. We just said that would be a vertical line. And so what this is telling me is that the x coordinate has to always equal 6 no matter what. The y coordinate can be anything. We can have y equals 0, y equals 1, y equals 2. The x coordinate can only equal 6 every single time. So what some students will do on the test, and also they get stuck on the homework because of this, they'll say, okay, x equals 6. They think of it like an x-intercept, right? They're like, okay, let's find 6 on the x-axis. They'll mark that point, and then they don't know what else to do. So they'll just leave their answer like that. Or they'll know, well, I'm supposed to get a line here, but it's not drawing a line for me. I'm marking this point, but I'm not getting a line. And they know they want a vertical line, but how do you make it draw a vertical line? You still have to plot 2 points. So to graph a line, you always have to mark 2 points for MathXL to be able to graph it. So you still need to plot a second point. And it can be any point you want as long as the x coordinate's equal to 6. So if you want to maybe make a chart like this, the point we've already graphed here is 6, 0. And so that's one point we could use. Let me try that 0 again. We need a second point. And the y coordinate can be any number I want. I can choose 1, I can choose 2, anything will be fine, but the x coordinate has to be 6 again. The x coordinate is stuck at the number 6. We can't choose anything else for x. So any of these other points would be fine. So 6, 1 would be fine. 6, 2 would be fine. 6, -5 would be fine. Any of these points would be fine. And once you have 2 points, MathXL will draw the vertical line for you, right? And so, gosh, why do I keep doing that? All right, so let's try to draw a vertical line here. I'm doing a horrible job. Okay, so there we go. And again, it should go this way as well. And it's a little bit, there's a little bit of a disconnect there, but you get the idea. So we have this vertical line connecting those 2 points, or those 4 points that we actually drew there. Okay, let's get I gotta be done here. This is I'm starting to fall apart. So actually, I think I am done. That's the last example, really. I should have one more. Let's do one more. I'm just going to throw it on the screen. Y equals, oh, I do have it. It's down here, but you can't see it. All right, so there's this, I thought I wouldn't just do a vertical line, so there needs to be at least a horizontal line as well. But it looks like it got cut off. So I'm just going to make one up here. So we'll have Y equals -2, for example. So I'm sorry this doesn't match what's on the notes for my outline. This will be a horizontal line. All right, so this will be a horizontal line. Same idea as this one, except this one, the y-coordinate is stuck. The y-coordinate is fixed at -2. It can never equal anything else. The x-coordinate could be any number you want. So we could have 0 for x, but the y-coordinate has to be -2. We could have 5 for x, but the y-coordinate has to be -2. That's what this equation is telling us. It doesn't care what x is equal to. The y-coordinate is always -2 no matter what. So if you only find -2 on the y-axis here, by looking at this equation, again, that's not enough to get the right answer, right? This isn't just a point. This is going to be a line. And in order to draw that line, you need at least 2 points. This is one point that you can use, the y-intercept of -2, but you need at least one other point. So we're using 5, -2 here. But you could also use -3, -2, 1, -2. Any of these would be fine. They would all give you this horizontal line here that passes through -2 on the y-axis. So I keep doing that. That's really weird. So let me draw it this way. This will be better, I think. So there you go. So there's our horizontal line at y equals -2. So let me go ahead and end this video before I make any more gaffes. So the next section will be section 1.4 on more about graphing lines. All right, thank you for watching the video.